Welcome to the Principles of Success, Interviewing the Experts. My name is Nathan, and today's book review is How to Lie with Statistics. Now, I want to clarify real quick. I will be using examples of political lies with statistics and health lies with statistics. That's because the three biggest fields that are guilty of lying with statistics are marketing, political, and health. So, when I use these examples, I'm not trying to attack anyone's ideologies directly. Not yet, anyway. I'll do that later, at least with the health. But I am trying to just show examples that you might have heard and maybe even believed that are completely false and are real-world examples of you falling to somebody lying with statistics. And that's what this book is really about. It's not teaching you how to lie with statistics. It's teaching you how you are lied to with statistics and how to spot the tactics that are being used against you to shape your perception. And this is a really important book. There's a reason why it has been found on most influential people's reading lists. Bill Gates is one of those people who have it included. And you don't need to be even very knowledgeable in math. You don't need to be a statistician. You can be just an average bloke to understand and get value from this book. So don't let the fact that it's talking about statistics scare you off. And the first tactic that is used to fudge the numbers is biasing your sample. So the example I'm going to use for this is a poll on President Trump that came out last month, I believe. And again, not being political with this, I'm just using it as an example. But this poll is a perfect example of biasing your samples. And what it means is, ideally, you have a sampling of an evenly broad spectrum of people. But you can fudge the numbers by stacking the people who will most likely give you your desired outcome in the sample group. So for example, in this example, this poll on a Republican president only contained 20% Republicans. So if you want to get an approval rating of what Republicans think of their Republican president, then you would probably do 100%. If you want an approval rating for what America thinks of the president, you would do probably about 40% Democrat, 40% Republican, and 20% Independent, or even 33. That's a lot more even. But with it only being 20% Republican, the pollers were then able to sway the numbers in their favor. And that's just a perfect example of using a biased sample. So whenever you look at a statistic, look at what the sample is. Another example of this is by gender. If you want to stack the study in favor of women, for example, you might have it be 70% women, 30% men, and that will skew the results in favor of women. These are just commonplace examples of biasing the study group in order to sway the outcome. The next tactic that I want to talk about is using the mean instead of the median. Now, if you're like me, I barely remember what mean, median, and mode means. But the importance of knowing which way they're measuring the average helps indicate if you're being lied to or not. So the problem with mean is it gets skewed by outliers. So let's use just a random example of, let's say there was 10 people and 9 of the 10 scored 1 point, but that 10th person scored 10 points. How most of us would think of the average is the average is 1 point. That's what most people got. That's what the average is. But when you use the mean average, the average is like 5 or 6 points because of that one person who scored so many points. So when you hear the average person scores 6 points, you think that most people score 6 points. However, it's not true. It's just because of one outlier that was able to skew that number. So in the book, he uses an example of housing prices. And the realtor might say the average house price is $300K. Most of the houses on the block are only $100K. But there's this one super fancy mansion at the end of the street. That's a real world example of this being in play. The next tactic I want to talk about is using small samples. In health or in science, generally this is called antidotal. I can't say the word. I said it earlier. Antidotal, good enough. Antidotal evidence. Basically, it means that because it worked good for me, does not necessarily mean it'll work good for you. This tactic is most often used in supplement industries. It's like, well, these 20 people got a bonus from it. So we're going to say that these 20 people represent the whole population, even though these 20 people represent a small fraction of the population and probably a small demographic, back to biasing your sample. The 20 people could all be young adult males in their 20s who are athletes. And they're like, yeah, they got a great boost from this. You should try it too. Actually, a perfect example of this is Gatorade. If Gatorade's terrible for you, it's okay if you're doing a ton of athletic performance. But for 99% of you, you're not an athlete. So Gatorade is just glorified pop with a little bit of salt added in. So when you look at a statistic, check out how big of the group it was, because if it's a super small sample, odds are it's probably not very accurate, especially when we talk about the next tactic, which is deviation/variance. And basically what it means is statistics are not 100% accurate. Tests are not 100% accurate. The example he uses in the book is the IQ test, which I personally disagree with, but that's not the point of this. The IQ test has a variance of plus or minus 3. So let's say, for example, John got 98 and Sally got 102 for their IQ. Well, the actual measurements is John is somewhere between 95 and 102, and Sally is somewhere between 98 and 105. When you just look at the 98 and 102, you make the assumption that Sally's the smarter one, according to IQ tests. But it could be that Sally is actually 98 due to variance, and John is 102. So John is the smarter one. But because of the lack of displaying the variance, you would assume that Sally is the smarter one. How this is most often used is in the example I'll use for this is the calories on your food package. I also disagree with calories, which we'll talk about more in health, but when we talk about the health principles. But the calorie on the package is a flat number. The problem is not everything is the same size. It's like trying to say a scoop of ice cream is 100 calories. Well, how big is the scoop? Is it a small scoop or is it a big scoop? So that's another tactic that is commonly used and is most often combined with one of the other tactics. In fact, you can combine any of these tactics together to really sway the results. That's why anytime you read an article about a statistic, you need to be very skeptical unless you look at the actual statistic, because it could be a study completely full of holes, and you'll never know because you'll never hear about it because you only ever read the article. But back to what we were talking about. The next tactic is related to what I was just talking about with calories, and it is correlation does not equal causation. So I'm sure you've heard by many an individual that I'm trying to cut calories. The amount of calories you take in are not necessarily the reason why you gain or lose weight. Calories are a correlation. They do not predict how much weight you gain and how much weight you lose. Part of that is due to human beings and their variance on their metabolism. And part of it is just the quality of the calorie. I promise you, if I eat 10,000 calories of meat, vegetables, and fruit versus you who only eats 1,000 calories of sugar, grains, and alcohol, I will be the healthier, more fit individual by a long shot. So, how statisticians use correlation to affect things is rampant in the health industry, ridiculously rampant. It's also, and part of that is because the human body is so complex that it's really hard to pin down exactly what causes what. One of the few times where we actually have proven something causes something is cigarettes causing cancer. That's one of the few times where we had a big enough sample size, the whole world, to definitively know for sure that cigarettes caused cancer. But you'll hear all the time, especially in health and especially in politics, science proves something, and it's just a correlation. It's not necessarily what causes it, it's just there's a link somewhere between here. A statistical example of this is hot fudge sundaes, or a statistical example of a inverse correlation is hot fudge sundaes go up, or hot fudge sundae sales go up when umbrella sales go down. Umbrella sales going down does not cause hot fudge sundaes to go up. The weather is the cause for hot fudge sundaes to go up and weather sale or umbrella sales to go down. So just because they're correlated does not necessarily mean that one causes the other. And then the next tactic is relative versus absolute risk. And I'll use the study of bacon as an example. There was a study that came out, and you might have seen articles about it, that said eating bacon increases your chances of cancer by 10 times. The problem with that study or the problem with those articles is, we'll talk about the problem with those articles next, but what relative versus absolute risk is, for example, an absolute risk of the bacon is you have a 0.001% chance of cancer if you never eat bacon. You have a 0.005% chance of cancer if you eat 3 pieces of bacon every single day for your entire life. That is not that big of a chance that bacon causes cancer. However, that's the relative risk. The absolute risk is, with my numbers, bacon is 6 times, eating bacon increases your chances of cancer by 6 times. So that's also a way that you can use a statistic like the small variable increasing by a small amount, but because it was so small, it increased by a lot. You can use that to then frame a statistic that it is, I don't remember where I was going with this sentence. Basically, when you hear a 10x, 5x number, they're using absolute risk over relative risk. And relative risk is the true number, and absolute risk is the sensational number. So you might have a teeny tiny % chance of getting cancer from eating bacon, but because people who eat bacon have a small percentage chance of having cancer more than people who don't, then they can say bacon eaters are 10 times more likely to have cancer. And I'm not promoting bacon. I do like bacon, and for some people it is actually a healthy thing to have in your diet. But I'm just using it as an example of taking a small number, but because it was so small and it had a significant amount of change, they can then use that to promote a ideology that isn't actually supported by the statistics, but they're able to use it anyway. Which brings me to the last way to lie with statistics, and that is called the post hoc tactic. Basically what this is the simplest example is you take a bow and arrow and you shoot into the side of the barn, and then you go and draw the bullseye around the arrows that you shot. So when you show it to people, they go, "Oh wow, you're a really good marksman. You got all those arrows in that bullseye." Whereas in reality, you painted the bullseye around the arrows. And in the real world example of this is one of the most infamous examples of this, where it caused a ton of damage. The Mediterranean study, also known as the Seven Nations study. And this is the study where fat was villainized, where meat was villainized. For all of human history, meat was considered the most important food in existence. That's why it's called protein, because it was priority. Then in about 1950, a scientist, quote unquote, by the name of Ansel Keys, had a hypothesis that meat caused heart disease. And he did this big study where he studied all sorts of nations in the Mediterranean, which is Europe. And then his study came out, and the conclusions were meat causes people heart disease. The problem is he went into that study wanting to prove his hypothesis instead of disprove it, which is very bad for scientific study. The other problem is he tossed out key study findings in order to prove his hypothesis. So by the post hoc tactic, in more modern day language, is called cherry picking data. And that is how meat got villainized. That is also how we got the statistic of 97% of 97% of climate change scientists agree in global warming. The actual statistic for that, or how that statistic came about, is a group of activists went through all of the different scientific papers of selected cherry-picked scientists, and the criteria was if they at least talked about global warming being real, then they were counted as believe in climate change. The problem is that includes people who are not sure that climate change exists, they're neutral, people who believe in climate change, or scientists who believe in climate change but don't believe that it's man-made, and scientists who believe that who believe in climate change but don't think it's a big deal, and climate change scientists who believe in climate change and actually think it's a good thing, and the ones that actually believe that it's bad and caused by man. Now, I'm not wanting to delve into the climate change arguments. I'm just pointing out that statistic because that's a modern day example of cherry picking data that will have massive ramifications on the world if it's not called out. If the science is accurate, it should stand up by itself. If not, then let it die. Either way, that's an example of post hoc, which is one of the most deadly tactics. And I just want to talk about the articles real quick. The problem with reading articles that are about science and health and stuff like that is these are news organizations that don't care if these are sensational articles that don't have to be accurate. If they're wrong, they'll publish a little note at the bottom. But how often have you gone back to an article you've already read to see them say, yeah, this isn't accurate? So when you're studying stuff like health, like politics, like anything involving statistics, make sure that you look at the actual studies and examine if they're using any of these tactics. This episode was a little long and probably a little dry, but I hope that you guys got some value out of it. I will see you all next week.